Welcome back, students, in a new video where I'm going to discuss about sound. So in this chapter, we are going to mainly discuss about what is sound, how do sound used to produce, how sound used to travel from one point to another point. Under that one, we will see for the propagation of sound. Then we are going to discuss about a little bit of vibration and then different characteristics of sound. So let's start and understand about this. So when we come across for sound, then in physics, we know for this thing that the sound is a kind of acoustic wave which used to transmit through a particular medium when a body been vibrated or when you vibrate or when you cause vibration in a particular body, then that propagate the sound in the form of an acoustic wave through that medium. तो बेसिकली जब हम लोग बात करते हैं साउंड के बारे में तो हम लोग ये जानते हैं कि साउंड जो है वो एक ऐसा फॉर्म ऑफ एनर्जी है जो कि काउज होता है ड्यू टू द मैकेनिकल एनर्जी, बेसिकली बोल सकते हैं तो काइनेटिक एनर्जी उसमें मेन रोल निभाती है। तो जब भी किसी बॉडी में वाइब्रेशन होता है तो वो उस वाइब्रेशन को कैरी करता है आगे की तरफ इन द फॉर्म ऑफ काइनेटिक एनर्जी, एंड दैट इज नोन टू बी एज द साउंड एनर्जी और द sound which we can hear all around in different forms, whether it is the clapping of a palm or the vibration of the string or any other kind of sound whichever we used to produce or which we used to observe. So that is basically because of the vibration only. Under this one, we need to come across for the propagation of sound, where we need to understand that what does this propagation means. So when the sound is traveling, when the sound been allowed to move from one end to another end, or while the sound has been heard from the source to the observer, that is due to the propagation of sound. Means sound travels, and when sound used to travel, then it travels through a particular medium, because when sound needs to travel, then it requires particles, and the arrangement of particles which is present over there in a particular matter helps the energy to transmit from one end to another end. जब हम लोग साउंड को ट्रैवल करवाने की बात करते हैं, जब हम लोग कहते हैं कि साउंड ट्रैवल हो रही है एक पॉइंट से दूसरे पॉइंट में या एक टर्मिनल से दूसरे टर्मिनल में, तो हम लोग को ये समझने की जरूरत है कि वहां एनर्जी का ट्रांसमिशन हो रहा है। और जब एनर्जी ट्रांसमिट हो रही है तो एनर्जी कैसे ट्रांसमिट हो रही है? क्या पूरा का पूरा पार्टिकल ही एक एंड से दूसरे एंड चला गया, या फिर वो एक से दूसरे में एनर्जी को ट्रांसमिट कर रही है? तो प्रोपेगेशन ऑफ साउंड के लिए हम लोग यहाँ पर ऑब्जर्व करते हैं कि एनर्जी जो है वो पार्टिकल्स टू पार्टिकल्स ट्रांसमिट होती है, और यहाँ पर कंप्रेशन और रेयरफैक्शन का कंडीशन होता है जो कि साउंड को हेल्प करता है सोर्स से रिसीवर तक पहुंचने के लिए। जैसे कि फॉर एग्जांपल अगर हम लोग यहाँ पे देखते हैं, ये जो ट्यूनिंग फॉर्क है ये एक पर्टिकुलर साउंड प्रोड्यूस कर रही है ड्यू टू इट्स ओन वाइब्रेशन। यहाँ पर जो एयर मॉलिक्यूल्स हैं, ये एयर मॉलिक्यूल्स इस साउंड को कैरी करते हुए लेकर जा रही है वन टू अनदर टू द ऑब्जर्वर, एंड दैट ऑब्जर्वर can able to listen that sound. That is only the propagation of sound means, that sound is traveling through the particles, and as the particles are required, hence we say this thing that the sound requires a material medium to transmit. Without any material medium, sound is not able to transmit from one end to another end. So how can we come across this compression and rarefaction, which will help us to understand that how sound can be transmitted. So when we discuss about sound, then we know for this thing that as just now I was discussing, that it carries the energy from one end to another end. So say as for example, if we take for a particular matter and there are some particles, say as this is A particle, this is B particle, this is C particle, this is D particle, and so on and on. One more thing, when we come across for the arrangement of the particles, we know this thing that the arrangement of the particles used to be different in different states of matter. So whatever the states of matter, the particles are already present over there. The compression and rarefaction will take place in the same manner only. Okay, yes, the rate of compression and rarefaction can change, but the method of rare and compression will be same. So that only I want to make you understand over here. So say as for example, these were the particles and you had supplied energy from one end. Energy means you had caused vibration in the body. So when the vibration has been caused, then the first particle which had received the energy, it will move towards the particle B. This is considered to be as compression. When one particle is coming closer to another particle, this is called to be as compression. And after coming closer, it transmits the energy to the B particle and returns back to its previous condition. And this is known to be as the rarefaction. So when the particle is coming closer with the energy that to another particle, that is compression. And when it is returning back, then that is called to be as the compression. And this leads to the movement of particle B in the forward direction. Now the particle B will carry the energy to particle C, transmit it over there, and then return back. So this process will continue again and again from one particle to another particle, and this phenomenon only will help the sound energy to be transmitted from this one end to this end, and that is known to be as, or that is called to be as the condition of the propagation of sound. And as the particles are required to do this compression and rarefaction, thus we used to say this thing that the sound requires a particular material medium to perform this phenomena. And when we come across for the states of matter, then the speed of the sound used to differ from one to another with respect to compression and rarefaction. So what are the factors which used to determine the propagation of sound in a particular medium? So basically we can say this thing that the elasticity of the material, how elastic the material is, that determines that how the particles are going to vibrate, or how easily it is going to transmit the energy from one to another. The second one is the inertia of the particle that restores the mechanical energy. Means when the particles been excited, or say as for example, as I was telling earlier, that this is particle A and this is particle B. So when the particle A is at rest, then it has a inertia of rest. And when we had supplied energy to it, when we had supplied the kinetic energy to this, then this body came to in motion. Then it changed its inertia of rest to motion, and it comes closer to particle B. So when it comes closer to particle B, then this body A is going to change the inertia of particle B from the inertia of rest to inertia of motion. This used to cause a particular, this used to do a particular amount of work. So the inertia of the matter, or the inertia of the particle, also plays a very important role under the condition of propagation of sound, that how the sound is going to propagate from one terminal to another terminal. And the last thing which we need to understand, that the medium which we are using, there must be a frictionless condition. Frictionless condition means that the friction which is acting between the particles. So in different matters, we know this thing that matters contain particles, but the arrangement of the particles inside over there, that creates an internal friction, and which is also called to be as the viscosity of the material. And if the viscosity will be more or less, then it will impact the rate of propagation of sound. तो अगर इनमें से किसी भी पॉइंट को अगर हम लोग देखते हैं, तो ये सभी पॉइंट किसी ना किसी तरीके से एक दूसरे को कॉन्ट्रास्ट करती है, और इनके कारण ही हम लोग जो प्रोपेगेशन ऑफ साउंड देखने वाले, प्रोपेगेशन यानी जैसे कि ट्रैवलिंग ऑफ द साउंड देखने वाले हैं किसी मीडियम से, वो एक दूसरे से वेरी करती है या एक दूसरे को किसी न किसी तरीके से इम्पैक्ट करती है. तो ये तीन बेसिक से फैक्टर्स हैं जो कि प्रोपेगेशन ऑफ साउंड को डिटरमाइन करते हैं. सो वंस अगेन, इलास्टिसिटी ऑफ द मटेरियल, the inertia of the particle, and the frictionless condition of the particles, due to which the energy should lose minimum. क्योंकि एक पार्टिकल से दूसरे से तीसरे से चौथे से पांचवें, जैसे जैसे वो आगे बढ़ते चले जाएगा, जितनी ज्यादा इंटरनल फ्रिक्शन होगी, एनर्जी उतना कम होगा, और एनर्जी जितना कम होते चले जाएगा, जो डिस्टेंस है साउंड के ट्रैवल करने का, वो घट जाएगा, because the particles will consume all the energy and it will not be allowed to transmit the energy in the forward direction. And when we come for all these things, then we can understand one very simple principle with this, that the sound is not can be heard in a vacuum, because there is no any medium. If there is vacuum, then there is no any medium. So what would happen? It will not carry the vibration. It will not cause the propagation of sound. So the propagation of sound is not possible in vacuum, but it can be possible in any of the states of matter, whether it is solid, liquid, or gas. Now, before we go further, when to understand some more things, we need to understand these basic terms related to the sound, or the wave of the sound. We all know this thing that sound used to travel in the longitudinal wave, which we had studied in our previous class also. So what is the wavelength? So under a condition where we are drawing the wave, such as this is the wave which we had drawn, then one complete crust and one complete trough forms the wave over here. So this column from this to this length is called to be as the wavelength. And this is the main thing which we need to remember. One crust with one trough is the wavelength. And when we need to measure this length, we come across with the unit as meter only, with which is the SI unit of length. And when we need to denote this wavelength, then we use the Greek word that is lambda. Next, which we need to understand, that is the amplitude. So what is the amplitude? Amplitude is the maximum displacement of the wave from its mean position. So when the wave used to be caused, then the maximum displacement which used to cause by the wave over there, that is called to be as the amplitude over here. So this one can be understood like this. Suppose, for example, there is a pendulum. So till the height it has been lifted to one end, that would be called to be as the amplitude. In the same way, when a particle been hit by any body or caused vibration in that one, then how fast it had excited itself and moved from its mean position, that will give us the amplitude over there. Next, the time period. So what's the time period? Time period is the time taken by this by the wave to form over there. So this is the time which is required for a wave to form. Okay, one wave to form. So one crust with one trough. So that is called to be as the time period. The next thing which we need to remember, that is the frequency of the sound. So the total number of complete waves formed in 1 second, okay, in 1 second time period, the total number of waves which used to be caused, that is called to be the frequency of sound. So when we come for the frequency, that is the total number of waves that can be observed in 1 second. And at the very last, we need to understand the term that is velocity or the speed of the sound. So when the sound been produced from a source, then the sound carries on or travels in the forward direction. It travels in the forward direction like this. So when it is traveling in a particular direction. Hence, and one more thing, it is covering a certain distance. So when it covers a distance in a period of time, then we need to calculate its speed also, that how quickly it is reaching from the source to the observer. That gives us the velocity. So this is one of the topic which we need to remember. So all these terms we had discussed in our junior classes also, but you need to remember all these things, because these things are going to helpful for you in your future classes also. So it's not like that only in this class you have to just go across for these things. These are very, very important things which you need to understand in your future classes also, and you have to use them also. Now, when we come across for the wave, then we go for its two basic graphical expression, that is the displacement time graph and the displacement distance graph. तो जब हम लोग वेव को फॉर्म करते हैं, तो वेव के फॉर्मेशन में हम लोग इन दो ग्राफ को देखते हैं. तो सबसे पहले तो हम लोग को समझने की जरूरत है ये वेव बनता कैसे है. So just a minute, with this white page, I will explain you that how this wave used to be formed. First of all, how we can go for this longitudinal wave. Longitudinal wave का formation कैसे होता है. तो देखो हम लोग यहाँ पर जो x एक्सिस और y एक्सिस है, इन दोनों को ले लेंगे. हम लोग जैसे कि जब हम लोग मोशन चैप्टर पढ़ रहे थे, तो वहां पे हम लोगों ने समझा था कि फर्स्ट क्वाड्रेंट और द फोर्थ क्वाड्रेंट, इन दोनों क्वाड्रेंट्स का इस्तेमाल किया करते हैं हम लोग मोशन को दिखाने के लिए. तो यहाँ पर भी हम लोग मोशन ही दिखा रहे हैं, तो इसीलिए हम लोग फर्स्ट क्वाड्रेंट और फोर्थ क्वाड्रेंट का इस्तेमाल करेंगे. So how can we do that, this one? So see, for example, as I was doing earlier, this is particle A, this is particle B, this is particle C, D, and so on. So if you had caused vibration in this particle A, what will happen? It will become excited. उसके पास एनर्जी आया, तो वो इसके पास जैसे ही एनर्जी आया, ये एक्साइटेड हो गया. ये एक्साइटेड हुआ और एनर्जी को लेकर आगे की तरफ बढ़ा. ये एनर्जी को लेकर आगे की तरफ बढ़ रहा है और फिर वो वापस पीछे की तरफ आ जाता है. यानी एक बार कंप्रेशन किया, एनर्जी को ट्रांसफर किया और फिर अपने पुराने जगह पे, यानी वो रिटर्निंग बैक टू इट्स ओन पोजीशन या ओरिजिन में आ जाता है, जिसको कि हम लोग दिखाते हैं रेयरफ्रैक्शन से. तो यहाँ पर हम लोग इसी चीज को दिखाएंगे. यहाँ पर क्या हो रहा है, जैसे ही पार्टिकल को एनर्जी मिला, वो एक्साइटेड होकर वो ऊपर की तरफ गया और फिर वो दूसरे पार्टिकल्स तक पहुंचकर उसको एनर्जी ट्रांसमिट कर दिया. उसको एनर्जी ट्रांसमिट करने के बाद वो फिर से वापस अपने पोजीशन पर वापस आ गया। सो ये जो कंडीशन है, इस कंडीशन को अगर हम लोग देखते हैं तो इस कंडीशन में ये रिटर्न बैक टू इट्स ओन पोजीशन आ गया जहां से वो ओरिजिन किया था। तो ये एक सिंगल पार्टिकल का हम लोग मूवमेंट दिखा रहे हैं। तो यहां पर हम लोग इसी चीज को समझने की कोशिश कर रहे हैं कि जो ग्राफ दिखाया जा रहा है ये पार्टिकल्स का, अब ये पार्टिकल में एनर्जी मिला, ये एनर्जी मिलकर एक्साइटेड हो गया, वो ऊपर की तरफ गया एनर्जी के साथ, फिर वो दूसरे पार्टिकल्स तक पहुंचा, दूसरे पार्टिकल को एनर्जी देते हुए वो फिर से वापस आकर अपने ओरिजिन में चला गया। यानी नीचे का जो ट्रॉफ होता है ये दिखाता है रेयरफ्रैक्शन, और ऊपर वाला जो क्रस्ट होता है वो दिखाता है कंप्रेशन। And this will carry on, this will carry this energy, and it will be transmitted further. अब now जो पार्टिकल B है वो सेम, जैसे ही पार्टिकल A से उसको एनर्जी मिलेगा वो आगे की तरफ बढ़ेगा, और वो आगे की तरफ बढ़कर और आगे की तरफ बढ़ जाएगा। लेकिन यहाँ पर हम लोग देखेंगे एम्पलीट्यूड थोड़ा सा कम हो गया है। हम लोग आगे के क्लासेस में इसको पढ़ेंगे जब हम लोग समझेंगे डंप वाइब्रेशन। डंप वाइब्रेशन क्या होता है, तो इससे एक पार्टिकल से दूसरे पार्टिकल में जब एनर्जी ट्रांसफर होती है तो थोड़ा सा एनर्जी घट जाता है, जिसके कारण यहाँ पर एम्पलीट्यूड थोड़ा सा छोटा हो जाएगा पहले के मुकाबले में। And similarly it will carry on, but that we don't have to study right now. We will study it in our next class, in class 10th we will see for that one. But right now we need to understand this thing, that the energy been transmitted, and this shows the change in the condition of the particle with respect to the time period, and that is only the thing which we are going to discuss over here. So in this graph which we are going to study over here, the first graph which we are going to discuss, that is the displacement time graph. In this one we are actually representing the movement of the particle only. हम लोग जो यहाँ पे जो ये ग्राफ जो कर रहे हैं डिस्प्लेसमेंट टाइम ग्राफ, ये असल में पार्टिकल्स का मूवमेंट ही दिखा रहा है कि वो टाइम के साथ किस तरह से अपने पोजीशन को चेंज कर रहा है कंप्रेशन और रेयरफ्रैक्शन को करते हुए। और यहाँ पर हम लोग एक चीज याद रखेंगे कि जो हम लोगों का एक्स एक्सिस है वो टाइम दिखा रहा है इन द पीरियड ऑफ इन द यूनिट ऑफ सेकंड, एंड यहाँ पर जो ये वाई एक्सिस है ये हम लोगों का डिस्प्लेसमेंट दिखा रहा है। डिस्प्लेसमेंट मींस एम्पलीट्यूड दिखाया जा रहा है यहाँ पर कि वो कितने हाई तक गया है एनर्जी के साथ, जो कि यहाँ पर मीटर में हम लोग यूज कर रहे हैं। So this is the thing which we need to discuss for the condition of displacement time graph. And when you come for the displacement distance graph, then it represents the condition of displacement of one particle from its mean position, as well as it gives us the understanding that how far this energy has been transmitted. यानी वो एक पार्टिकल से दूसरे पार्टिकल के बीच में एनर्जी ट्रांसफर कर रहा है, ये तो कंप्रेशन और रेयरफ्रैक्शन से डिस्प्लेसमेंट टाइम ग्राफ में तो दिखाया ही। लेकिन यहां पर हमको क्या दिखाया जा रहा है, ए पार्टिकल से बी पार्टिकल एनर्जी कितना गया, उसका मूवमेंट कैसे हुआ, और ये कितनी दूर तक गया। यानी वो सी पार्टिकल, डी पार्टिकल, ई पार्टिकल, एफ पार्टिकल्स, जी पार्टिकल्स कितनी दूर तक वो ट्रैवल कर रहा है, इस चीज को भी हम लोग यहाँ पर दिखा रहे हैं विथ रिस्पेक्ट टू डिस्प्लेसमेंट डिस्टेंस ग्राफ. So these were the two basic graphs which we need to understand while we discuss about the sound energy, or while we express the components of the sound energy. Now, let's understand some of the relation between the terms which we had discussed. हम लोगों ने डिस्कस किया था पीछे वेवलेंथ के बारे में, फिर हम लोगों ने डिस्कस किया था फ्रीक्वेंसी के बारे में, फिर हम लोगों ने डिस्कस किया था वेलोसिटी के बारे में, फिर हम लोगों ने डिस्कस किया था टाइम पीरियड के बारे में. Now students, there is a particular relation between all these things. इन सब के बीच में एक सिंपल सा रिलेशन है. The lambda, when we come for the lambda, which is the wavelength over here, you can consider this one as the displacement. यहाँ पे तुम लोग इसको distance या displacement के रूप में समझ सकते हो. Then we go for the unit as velocity into time. This is the velocity into time. Okay, and there is a relation between the time and the frequency. So time is equals to 1 by f. Why it is so? See students, it's a simple unitary method. As we know this thing, that time period is the time taken by one wave to complete its one oscillation, and f means the frequency. It is the total number of oscillations that took place in 1 second. So suppose in 1 second there were 10 oscillations done. So 10 would be the frequency. 10 would be the frequency which will be represented in 10 hertz. Then what is the time period for one frequency, one wave to form over there? So that would be 1 by 10. Hence, we establish the relation it as t is equals to 1 by f, or we can go for this thing, f is equals to 1 upon t. So over here, we can have the formula as wavelength equals to velocity into time period, or we can go for a formula where we can say the wavelength is equals to velocity upon frequency of the sound. So these are the simple terms which you need to remember when you come across for the relation between the velocity, frequency, and the wavelength. Now let's understand about the speed of sound. So when we go for different mediums or different materials, material mediums, then we used to observe that the sound used to have a different speed over there. And all the materials which we are using with the respect to their density and their presence, we observe that the speed of the sound used to be different. A general concept is there that of the higher density, the sound, the speed of the sound would be greater over there. But not only the density is the factor, but else than density, there are some other factors also which used to determine the speed of the sound. So let's understand about that. So when we come across for the speed of the sound in a given medium, so whether it's a solid, liquid, or gas, then we used to have a particular formula. And with respect to that only, we can establish a final formula. So when we come across for the sound, then we say this thing that the sound gets affected by the elasticity of the material, the density of the material, and with respect to that only, we can understand the condition over here. So here I had used the speed of the sound in the gaseous component only. So we can say, for example, if we are talking about the speed of the sound in a solid body, then we can say over there, or we can observe that thing, that the velocity of the sound is directly proportional to the square root of the elasticity of that particular material. Or you can say this thing, the square of the velocity of the sound is directly proportional to the elasticity of the material. So take it as equation 1. The next factor which is present over there, that is the velocity of the sound, is inversely proportional to the density of the material of the sound, or you can say it as the square of the velocity of the sound is inversely proportional to the density of the material of the sound. Now if we use these equations over here, then what we can come across, we can say this thing that the v square is directly proportional to the product of the elasticity with the reciprocal of the density. So over here, v square is directly proportional to the value of elasticity upon density. Now we can remove this directly proportional sign with the value of equals to with the proportionality constant value. Proportionality constant value over here we are using as the gamma. Okay. So what does this gamma is representing over? This gamma is very important. This gamma is actually representing a constant value of pressure with respect to the volume. Okay, so when we are coming for the density of the material, then at what pressure and volume we are comparing it, that gives this constant value. So this comes as E upon rho. So therefore we come to the final value, that is V, means the velocity of the sound is equals to a square root under the gamma with elasticity upon the density. So this is the formula by which we can calculate the velocity of the sound, or we can go across for the velocity of sound in a particular solid material. If I am talking about a solid material, then we can use this particular formula. And when we come for the gaseous things or any other component, then we can basically say that the density is only important factor over there. But else than density, the elasticity of the material is also very important. Okay, don't get confused with the value, with the sign E and capital P. So they both are represented for the elasticity only. Now, if we come for the condition of the temperature, then we observe this thing that the temperature used to affect the speed of the sound in a little different way. So the speed of the sound in a gaseous component, if we see, then as the temperature increases, the speed also gets increased over there. So the reason is that with the increase in temperature, the density of the gas decreases. Consequently, the speed of the sound increases over there. So as the density increases, okay, with the change in the temperature, as we know for this thing that as we are increasing the temperature, we know this thing that there would be a decrease in the density. So with respect to that one, we know for this thing that the velocity of the sound is inversely proportional to the square root of the density of the material. So as the temperature increases, the density decreases. Hence, we observe this thing that the velocity of the sound is also increasing over there. Now, this also shows one very important thing. As the density decreases in the gases, we observe that the random motion of the particle gets higher. And because of this random motion which takes place in the gaseous particle more rapidly, because of that only, or due to that particular nature only, we do observe that the sound increases its speed more rapidly over there. So these were the things which we need to understand for the concept of the speed of the sound for the case of gases or the solid or the liquids only. Now, one more factor which we so not one, there are two more factors which we need to understand for the condition which is impacting or which creates the impact on the speed of the sound. That is the humidity in the which is present in this in the air, as well as the direction of the wind. So when we come for the humidity, then we observe that the speed of the sound in the air increases with the increase in the humidity in the air. So जैसे जैसे हवा में humidity का percentage बढ़ता है, वैसे वैसे sound की speed भी वहां पर increase हो जाती है. तो ये नॉर्मली देखा गया है कि जब साउंड जब वाटर मॉलिक्यूल्स की डेंसिटी या सॉरी जो वाटर मॉलिक्यूल्स की जो प्रेजेंस है एयर के अंदर, वो जैसे जैसे इंक्रीज हो जाती है, जो एवरेज डेंसिटी है वो डेंसिटी वहां पर इंक्रीज करने लगती है. एवरेज डेंसिटी का मतलब हो गया डेंसिटी ऑफ वाटर विद द डेंसिटी ऑफ एयर. तो डेंसिटी के साथ हम लोग वहां पर देखते हैं कि वहां पर एक चेंजेस आने स्टार्ट हो जाती है, और इसी चेंजेस के कारण हम लोग वहां पर स्पीड में या तो स्पीड वहां पर डिक्रीज कर जाती है या तो स्पीड वहां पर इंक्रीज कर जाती है. सो वंस अगेन द स्पीड ऑफ द साउंड इन एयर इंक्रीजेस विद द इंक्रीज इन द ह्यूमिडिटी इन द एयर. तो जैसे जैसे चेंज होती है ह्यूमिडिटी, वैसे वैसे हम लोग देखते हैं वहां पर जो स्पीड जो है वो भी वहां पर डिफर हो जाती है. तो ये एक बेसिक सा कॉन्सेप्ट है जिसको कि हम लोगों को याद रखने की जरूरत है. और अप्रोक्सीमेटली वैल्यू जो होती है, वैल्यू वहां पर 5/8 टाइम्स के इंक्रीजिंग के वैल्यू से देखते हैं. खैर, जो नेक्स्ट टर्म हम लोगों को समझने की जरूरत है वो है इफेक्ट ऑफ द डायरेक्शन विद द विंड. सो जब साउंड की स्पीड के बारे में बात आती है, तो विंड की स्पीड भी इसमें एक रोल प्ले कर सकता है, जिसको कि हम लोगों को समझने की जरूरत है. और इसको समझने के लिए हम लोग एक सिंपल से एक्सपेरिमेंट से समझ सकते हैं. सपोज देयर इज अ स्पीकर, okay, and it is propagating the sound in the forward direction, and the wind is continuously blowing in the same direction. So what will happen, it will allow the particles to vibrate, and as well as it will not to vibrate only, I will say that it will help the particles to make the transfer of energy in a very easy manner. It will allow the particles to move in the forward direction, and it will give it a chance that that the sound can be traveled to far distance in a very easy way. So we can observe this thing that with the increase in the temperature, with the increase in the speed, we can observe that the increase in the speed of the sound can be also observed. So with the speed, as the wind's speed increases, it increases the speed of sound. So these are the things which which we need to remember. And one of the things which you need to remember, that the factor which doesn't affect the speed of the sound, that is the pressure, amplitude, wavelength, and the frequency. So these components used to play a role under the condition of other characteristics of sound, such as loudness, pitch, the quality of the sound, but they doesn't have any role to play under the condition of the speed of sound. So when we compare the speed of sound in different mediums, such as, for example, the solid, liquid, and gas, we do observe this thing that different bodies do have a different rate of speed to make the sound to travel from one to another. So in comparison for the solid, liquid, and gas, we know this thing that in solid, the sound speed is maximum, because over there the particles are very closer to each other than compared to liquid and gases. And as we come for the liquids, then we observe this thing that in the liquid, comparatively than to the solid, we observe this thing that the sound can easily transmit, but its speed decreases from solid, but its speed is still more than to gases. And when we come for the gases, we know for this thing that in the gases, the speed of sound is minimum, as the particles are having maximum of distances. So the role of the density or the arrangement of the particles, they play a very important role under the condition of the speed of sound. And that depends in each and every condition. Now, when we compare the speed of the sound with respect to the light, then we observe that there is a huge difference between both the components. So the speed of light in normal air is around to be 340 or 330 meter per second, and when we come for the speed of the sound in air, it is either 3 into 10 to the power 8 meter per second, which is the maximum value, or we can say it as 2.8 to 2.9 into 10 to the power 8 meter per second. So when we are comparing this value to this value, then we used to observe that the sound is very slow than to the speed of light, and the light is very fast. Light strikes very fast, and it travels very fast. So when we are comparing this speed, then we can find it out that why do we can hear the sound of thunder a little bit late than to the little bit late after we can see the flash of lightning. So the lightning can be seen instantly, but the sound of the thunder comes a little bit 2 or 3 or 4 seconds late after it. So it is because it has to travel a far distance with a slower speed, but the light can travel with that with a high speed. It can travel to the maximum distances. तो ये बेसिक सा डिफरेंस है जिसको कि हम लोगों ने छोटे क्लासेस में भी समझा हुआ है कि किस तरह से साउंड की जो स्पीड है वो लाइट के स्पीड के सामने में काफी छोटी हो जाती है। अब हम लोग चले आते हैं जो साउंड के जो जब हम लोग साउंड को क्लासिफाई करते हैं, जब हम लोग साउंड को कैटेगराइज करते हैं, तो उसमें हम लोग एक बेसिक सा कैटेगराइजेशन करते हैं जहां पर कि हम लोग समझते हैं विद द साउंड व्हिच वी कैन हियर एंड द साउंड व्हिच वी कांट हियर. Okay, so over there we differentiate this sound as in the form of the infrasonic, sonic, and the ultrasonic. So basically, this is the part of the audible and inaudible sound. So the sound range which is audible to us, means for the human being, that is called to be as the sonic sound. Means this is an audible range. So that is from the 20 hertz to 20,000 hertz. So this is the range of the sound which we human being can hear. So if a sound which has been generated less than 20 hertz, then that comes for the infrasonic sound, and the sound waves which is coming more than of 20,000 hertz, that is called to be as the ultrasonic, and both the sounds are inaudible to us. Means neither we can hear the infrasonic sound nor we can hear the ultrasonic sound. Only the sonic sounds can be here, and that is the range between the 20 hertz to 20,000 hertz. So that is the thing which we need to remember over here. So this is the concept which we had studied again in our junior classes, and we know there are several uses of infrasonic and ultrasonic, even though we are not able to hear it by our normal ears. But one more thing which we need to remember, that it is not necessary that we are not able to hear, so it is not been able to heard by any other organism. There are different animals who can be able to produce as well as hear infra and the ultrasonic sound. The very common example which we can give over there, that is our friend, any dog or a cat. So the pet dog or cat which you do have, they can have an ability to hear that kind of sound. Now, at the end of this chapter, we are going to see for the hypersonic sound. So what is hypersonic sound? So hypersonic sound is a kind of sound which is produced with a very high speed moving body. So such as, for example, when the aircraft used to travel, then it used to produce a sonic boom, because it travels with it more than the speed of the sound. तो जब भी हम लोग देखते हैं कोई भी जो 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 सुपरसोनिक प्लेन्स जो होती हैं, वो जब ट्रैवल करती हैं तो उसकी स्पीड काफी ज्यादा होती है। तो अगर वो उस स्पीड से वो बॉडी ट्रैवल करती है, तो वहां पर एक सोनिक बूम क्रिएट होती है। और ये जो सोनिक बूम है, इसी चीज को हम लोग कहते हैं हाइपरसोनिक साउंड। सो हाइपरसोनिक साउंड इज अ कंडीशन व्हिच यूज्ड टू काउज बिकॉज ऑफ अ हाई स्पीड बॉडी व्हिच यूज्ड टू ट्रैवल। तो अगर कोई प्लेन मार्क 1, मार्क 2 या मार्क 3 पे जाती है, मार्क 1, मार्क 2, मार्क 3 का मतलब होता है इफ इट crosses the sound barrier for once, twice or thrice, then it causes a booming sound, and that is called the hypersonic sound. So hypersonic sound is a kind of sound which is heard by our ears, and it is not depending on the frequency, but it depends on the rate of vibration, or it depends on the and the continuous extreme vibration in the air molecules, which creates the sound with a very loud booming condition. And that is only the thing which we need to understand over here. So with this topic, we come to the end of this chapter. I hope that in this chapter, all the components which we had came across, you had understood this. If there would be any kind of problem, we can discuss it in our class. And whatever problems you are having, you just note it down so that we can discuss it in our online classes. And further for this, that all the PDF notes, you can get it from our website. And with that only, I will end up this chapter over here. So thank you, everyone. We will meet again in the next video.